Alright, so let's say you're given this diagram, and the question says, pendulum of mass 1 kilogram undergoes constant circular motion around a horizontal circle instead of swinging back and forth, as seen by the diagram here. If the length of the pendulum is 2 meters and the angle theta is equal to 30 degrees, what is the force of tension in the wire? So, we can start off by drawing a diagram with our givens. In the question, it says the mass is 1 kilogram, the length of the pendulum is 2 meters, and the angle theta is 30 degrees. So we can plug these in for the pendulum values here, and then we can convert this to a free body diagram. Object we are going to be drawing the free body diagram for is the pendulum. So we can start with the mass equal to 1 kilograms, and then we're going to have the force of tension in the rope, and we can see that force of tension in the pendulum diagram here. It's going to be in this direction, and it's going to have an angle of 30 degrees with the vertical. We also have the weight force bringing it down. This is not part of the free body diagram, but we also have the acceleration radial. It's not a force, but I just put it there for context reasons, and you'll see why later. We can start by applying Newton's second law. Draw our x and y coordinate system here. We start by looking at the Newton's second law in the x direction equation. So our tension force can be broken down into Tx and Ty. Our sum of forces in the x is just going to be the tension in the x, so we can plug that in. And then we can note that the acceleration in the x is going to be equal to a rad, so that's why we drew that. And so we can plug that in, and then we can use trig to find the value of Tx. That's just going to be equal to T sine 30 because Tx is opposite of 30 degrees. If we plug that in, we can note that we have two unknowns, T and a rad. So we can continue by looking at the Newton's second law equation in the y. So we're going to have the tension force in the y and the weight. So we can plug both those values in, and then we can note that the acceleration in the y is going to be equal to 0 since the pendulum is only moving horizontally, which is in the x direction. We can plug in that, and then we can bring weight to the other side. We can use trig again to find the value of Ty, and that's going to be equal to T cos theta because Ty is adjacent to the angle. Plug in the weight force as well, equal to mass times gravity. Plug in our knowns given by the question, and we get this expression here. Compute the term on the right. Isolate for T by multiplying both sides by 1 over cos 45. Do a simple division, and we get this for the final answer. So this is going to be the force of tension felt in the rope. And so if we draw a diagram here, we have the velocity going around the circle. Then we have a rad always pointing towards the center, and then we have the tension in the rope equal to 13.9 newtons. And I just want to note, sometimes you only need to use Newton's law equation in one direction to find the unknown variable. And so we see when we use the Newton's second law in the x direction, we had two unknowns. But if we looked at the Newton's second law in the y directions, we had 0 unknowns. So that's actually all we needed to solve in this question. So this just goes to show that you should always apply Newton's second law equation in all directions appropriate for the question.